Hi, this is Brandon Baines in the Math Department at Lipscomb University, here to talk with you about modeling with functions. In this presentation, you'll learn how to model real-world scenarios using functions. Throughout App 1, we've seen that functions can be used to calculate future values, and we can examine the graphs of functions to make sense of applied situations. Some examples of the way we've done this include, for example, given some function p of t defined to be 3 times the quantity 2 to the 0.1t, where p of t represents the population of a certain bacteria at time t days. We might be interested in finding the population after 100 days. So our solution to this using functions would be to find p of 100. And doing so, we find that p of 100 is 3,072. And so we would say after 100 days, there are 3,072 bacteria. We could also examine the graph of the function that models this scenario. And again, we've talked about how we can describe the behavior of the graph and interpret that back to our scenario. So I've done this here, my observations. Some others certainly could be made. There are few bacteria in the Petri dish at time equals 0. I'll toggle back so we can point that out. We see here at time equals 0 is very low, perhaps none, but at any rate, our y-axis is scaled quite high. So very few bacteria at time equals 0. And then the population increases slowly at first, but then it grows faster as t increases. So we can see that here, sort of slow growth in the beginning, but notice between days 40 and 60, the increase is more. Between days 60 and 80, the increase is more. Between 80 and 100, the increase is more. So we see that the bacteria are not only growing or increasing, but they are increasing at an increasing rate. Take a look at another example. John and his wife Sally walk around their neighborhood at 4 miles per hour. We want to write the function for the distance that John and Sally travel after walking X hours. So our solution, we'll let d of x represent the distance traveled after X hours. And again, X is going to represent the amount of hours John and Sally walk. We need to come up with an algebraic expression that defines the relationship between the distance and time travel. One way we might start coming up with this equation relationship is to look at an XY table. If John and Sally walk 0 hours, then they will have gone, of course, no miles. If they walk 1 hour, they go 4 miles. If they walk 2 hours, they go 8 miles. 3 hours, 12 miles, so on. And so it appears that relationship should be that the distance is always 4 times the number of hours. And so that's d of x equals 4x. There are certainly other ways we could come up with this equation. And as we go throughout the course, we'll look at some very efficient ways of coming up with this equation as well. Now that we have a function that models John and Sally's walk, we can answer questions such as how far will they walk if they walk for 3 hours? And questions like if Sally wants to walk 10 miles, how long will Sally have to walk? Take a look at another example. Bargains Incorporated is having a Super Saver sale on outdoor patio furniture sets. The furniture sets are 45% off of the regular price of $630. Bargains Incorporated are able to purchase these patio sets at a cost of $200 each. And so we'd like to model this scenario using a profit function. We'll call it P of X, and that's going to represent the profit for selling X furniture sets. So let's let X equal the number of furniture sets sold. And again, P of X will be the profit. We might try to start coming up with this equation or this function by just thinking about the profit for selling one furniture set. So if we sell one furniture set, then the price that the customer pays is given by 0.55 times 630. That's because 0.55 because they're 45% off. And so that comes out to be $346.50. Of course, profit is going to be made after the $200 that Bargains has already paid. So we subtract these two. The cost that the customer pays is $346.50. Take away the $200 that Bargains paid for the furniture set. It gives you a profit of $146.50. Excuse me. So the profit per furniture set is $146.50. And so we have our profit function now. P of X is $146.50 times the number of furniture sets sold. Now that we have a profit function, we can answer questions like, what's the profit for selling 200 furniture sets? And also, how many furniture sets should be sold to make a profit of $10,000, for example.